All right, class, we're back with lesson 12, measures of center, variation, and position. And that's what we're going to do. We're going to find those measures today. So first, some vocabulary. A variable is a characteristic of a group of people or objects that can assume different values called data. Okay, so if we're asking people how old they are, the variable would be their age. The data would be the ages that you collect from the people that you ask. Data that can have units and can be measured are called measurements of quantitative data. Data that can be organized into different categories are called categorical or qualitative data. Some examples of both types are here. So measurement data or quantitative data are things that can be measured. I like that. So times, like seconds or ages, years, decades, stuff like that. Distance, miles, those aren't the only ones, but those are some examples. Categorical data is information that falls into a specific category and doesn't have necessarily a numerical value, although it could if it's not necessarily a measurement, like your favorite color, your hair color. A phone number, okay? Maybe your area code is 610, or it's 814, or it's 412, or 724. Those would be different categories of phone numbers based on area code. Okay, even though they're numbers, they're not measuring anything. They're dividing you up into different area codes. Okay, so measuring data in one variable is called univariate data, often summarized using a single number to represent what is average or typical. So a univariate data would be somebody's age. Measures of what is average is also called measures of center or central tendency, because the average, in one sense, can be thought about where the middle of a set of information is. Okay, so if you're talking to high schoolers and you're asking them their age, the average age would be what the middle age, kind of, so to speak, is for those high schoolers. The most common measure of center are mean, median, and mode. Okay, the mean is the sum of the values in the data set divided by the total number of values in the set. Same thing as average. Okay, median is the middle value. Now, lots of times people get mean, median, and mode mixed up. Median is the middle value if you put all the numbers in order. And if you can't get an exact middle number, you take the two middle numbers, add them up, divide by 2 to get the middle number. Okay, now median, I think, sounds a lot like medium. And if you think small, medium, large, medium is in the middle. So median is the middle. Mode is the value or values that appear most often. And if you look at the words most often, it starts off MO, just like mode, M-O-D-E. So if you put all the numbers in order and you pick off the ones that occur the most, not just ones that are repeated, but the ones that occur the most. So if you have like 5 6s and 5 7s, you would have 2 modes, okay, because 2 of them repeated the same amount of time. So a data set can have no mode, 1 mode, or more than 1 mode. The mode is the one that appears most often. If all of the numbers just appear one time, then there's no mode. Okie dokie. Alrighty. So example number 1, the table shows the number of hits Marcus made for the team. Find the mean, median, and mode. So here's his hits. So to find the mean, we're going to add them all up and divide by the how many there are. So we do 3 plus 6 plus 5 plus 2 plus 3 plus 7. Add those all up. There are 6 teams that they played, so divided by 6. So 26 divided by 6 is about 4 hits. Okay, I know it doesn't come out to exactly, it's like 4.5. So we just rounded down to the nearest hit. If that question came up on the homework, I would accept the decimal also. If you went out a couple decimal places, that'd be fine. To find the median, put the numbers in order from least to greatest and find the middle. Now 2, 3, 3, 5, 6, 7. If you count in from either side, 1 in, 1 in, 2 in, 2 in, 3 in, 3. The middle should be right there. So there is no center number exactly. So what you do is you take the 2 middle numbers add them up, which will give you 8, divide by 2. So the median would be 4 hits. Even though at no point did he ever hit 4 in a game, that would be the center of the information. So from the arrangement of the data values, you can pick off real quick that 3 is the mode because that's the one that occurs most often. All right. So Marcus's mean and median number for hits for these games was about 4, and his mode was 3 hits. That's how you kind of summarize your results in a sentence. Two very different data sets can have the same mean, so statisticians also use measures of spread or variation to describe how widely the data values vary. One such measure is called range, which is the difference between the greatest and least in a set of data. So you can have 2 people playing baseball and get the same average number of hits, but that doesn't mean they have the same type of statistics. Because one guy could average 3 hits per game and the other guy could average 3 hits per game. But the one guy could always be between 2 and 4 hits per game. But the other guy sometimes he could have no hits. Another game he might have 6 or 7 hits, but it averages out because his number of hits per game, each game is so variable. It changes so much. Whereas the other guy, he was always between 2 and 4 hits. So range, all you do is put the numbers in order and take the greatest minus the least, and that tells you how far it is between the biggest and smallest values. So the range in this example is 6 minutes. That's the time that it took Olivia to walk to school each day. So maybe on the day where she had 12 minutes, maybe she was running late and was speed walking, but on the days she had 18 minutes, maybe she dropped her books and had to pick them back up. Something like that. Obviously, she's not going to cyber school. So statisticians can often talk about the position of a value relative to the other values in a set. So quartiles are common measures of position. And when you see a word with quar in it, like quarter, quadrilateral, quad, that implies 4. So quartiles are common measures of position that divide a data set arranged in ascending order into 4 groups, each containing about 1/4 or 25% of the data. The median marks the second quartile, which is called Q2, and separates the data into upper and lower halves. The first or lower quartile, called Q1, is the median or lower half. The median of the lower half, while the upper quartile, Q3, is the median of the upper half. Now, I know that's a lot of words and a lot of new vocabulary words, perhaps, so I think an example is going to help out. So if we have this list of numbers in order, the middle splits the numbers right in half. That's the middle. Okay, that's called the median. Most of the time, we don't really call it Q2, but it's the middle. Call it the median. Now, if you go the lower half and find the middle of the lower half, that's Q1 or the lower quartile. And if you take the upper half and find the middle of the upper half, that's Q3 or the upper quartile. So in general, each quartile, you see how it broke it into 4 sections. There's this section, this section, this section, and this section. Each section has about 1/4 of the information in it. Okay? So the 3 quartiles, so the lower quartile, the median, the upper quartile, along with the minimum and maximum value are called the 5-number summary of a data set. Those 5 numbers tell you a whole lot of information about the data, about the set. So let's do a 5-number summary. The number of boxes of donuts Ang sold for a fundraiser each day for the last 11 days were, those values right there. Find the minimum, lower quartile, medium, upper quartile, and maximum of the data set, then interpret the 5-number summary. So we haven't talked about how to interpret it, so it's going to be key to take good notes in this section. So first thing you want to do is arrange the data from least to greatest. Now it's really easy to pick off the max and min. And then you would just count in till you got to the center number. And remember, if there is no center number, then you just take the 2 middle numbers and divide by 2. Then to get the upper quartile and lower quartile, you go from the middle number and just group the numbers above it find the middle number. In this case, it's 28. But again, if there were only 4 digits, 4 numbers here, you would take the 2 middle ones of the upper half, add those up, and divide by 2. Same thing with the lower half. If there is no middle number, like if there's 4 or 6 or 8 numbers on the lower half, you just take the 2 middle ones, add them up, divide by 2. Okay? So this is how we summarize it. The minimum is 14, the lower quartile is 17, the medium is 21, the upper quartile is 28, and the maximum is 35. Over the last 11 days, Ang sold a minimum of 14 boxes and a maximum of 35 boxes. He sold fewer than 17 boxes 25% of the time, because remember, everything below the first quartile is 25%. Fewer than 21 boxes 50% of the time. So if you go below 21, you have 25% here and 25% here, which gives you 75. And fewer than 28 boxes 75% of the time, because you got a quarter here, quarter here. Another way you could have said that is he sold more than 28 boxes 25% of the time. Or you could say 50% of the time he sold between 17 and 28 boxes. Just whatever you want to highlight. I mean, there's no hard and fast rule, and that upsets some people because they want to know, well, what's the right way to do it? You want to make sure you talk about the minimum, the maximum, and the middle quartiles in some manner. Okay? So if you do that, you're good. The difference between the upper and lower quartiles is called the interquartile range. So if you do Q1 and Q3 and subtract, that's the interquartile range, or we're going to abbreviate it IQR, and that has 50% of the information is contained there. So between 17 and 28, that's the interquartile range, and in this case, it's 11. So before deciding on which measure of center best describes a data set, check for outliers. An outlier is an extremely high or extremely low value when compared with the rest of the values in the set. To check for outliers, look for data values that are beyond the upper or lower quartiles by more than 1.5 times the interquartile range. So let's check that out. So students taking a makeup test receive the following scores: 88, 79, blah, 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 and so forth and so on. Okay? Identify any outliers in the data. So let's get the median, upper, and lower quartile. So we put it in order. Quartile 1 is 75. The median is 85, and the upper quartile is 89. Okay, so in this case, you had an even number, so there was no center, so we took the 2 middle ones, added them up, divided by 2, and then this lower half, or the upper half, had an even number of data points, so we had to get the middle, which you just add up the 2 and divide by 2. And also same thing with the lower half. There was 4 data values there, so there's no true middle value, so you take the 2 middles, add them up, divide by 2. Finding the interquartile range, you just do Q3 minus Q1, so 89 minus 75 or 14. So we use the interquartile range to find values beyond which any outliers would lie. So what you do is you take 1.5 times the interquartile range and you subtract it from the lower quartile to see how far down you can go without it being an outlier. And then you do the same thing, but you add it to the upper quartile to see how high up you can go. All right, so if I take the lower quartile and subtract 1.5 times the IQR, and then the upper quartile and add 1.5 times the IQR, you get 54 and 110. So that means anything between 54 and 110 is not an outlier. If I have something beyond 110 or lower than 54, it would be considered an outlier. So 45 can be considered an outlier for this data set. So find the mean and median of a data set with and without the outlier. Describe what happens. So we have our numbers. The mean, 79.6. We already found the median is 85. That's with the outlier. If I take out 45, notice we're taking out a number. So we're only dividing by 7. So the average actually, or the mean, goes up a little bit because I'm taking out that extreme value. So the median is also 88 this time now. So the removal of the outlier causes the mean and median to increase, but notice the mean is affected more by the removal of the outlier. Now the outlier will not always make the mean increase. It might make it decrease whenever you remove it. Okay, so the point is that the median is less affected by outliers than the average is. All right. So that's it for this section. Please reach out to me if you have any questions and continue on to your next assignment. Take care.